Hello again, my name is Neil Mullinger. I'm the Product Manager for Verification IP here at Synopsys, and I'm here with Bernie DeLay, who's our Director of R&D for Verification IP. In previous talks we've discussed the system Verilog architecture that we brought to memory verification IPs, and we've also talked about debug, and now we're going to bring those two things together in this talk. Imagine, if you will, verifying an SoC where you've got multiple protocols, you've got memory, and you're trying to debug an issue. Bernie's going to talk about protocol-aware debug and how that applies to protocols, and in particular in this talk, how it applies to memory.
Great, thanks Neil. Okay, as Neil said, basically I'm going to go through how you do debug more from a protocol perspective. In this case, the protocol is actually memories. So what we've done, maybe not too surprisingly, is we extended the technology that we had to do protocol debug in our protocol analyzer and looked at what was necessary to do effective memory VIP debug. If you look at this, a lot of this looks sort of familiar if you're familiar with our protocol debug in our tool. You still have a transaction view at top, okay, showing you in this case the particular transactions, because after all, something like DDR is still transaction based. In addition, in the case of memories, you probably see all the state machines. Okay, so this is all the state machines that are represented within a particular DIM out there. But in addition to this transaction and state machine view of the world, you probably also need a view of the actual memory array itself. And this, so on the bottom here, what we now have is a visualization of the memory array. Okay? That visualization again starts at time 0 at the top and goes down to the end of the simulation at the bottom. But when you think about a memory array, there's something else other than time you have to consider. There's another dimension. So while I can scroll through time, you also have to think about, I'm scrolling through an address range. Think of this as a window into your actual memory array that you can now visualize here at any moment in time by scrolling through the time window. Okay, so I can scroll for this address range, and if I scrolled along here, you'd see this window go through all the particular addresses. Or if I wanted a particular time and wanted to see what's happening from an address perspective, I would scroll the addresses within that time period. Okay? All right, so the other thing, in addition to visualizing the contents of the memory array that you probably need to know and understand is how did it get to that value? So we wanted to make that as simple as possible for you. If you think about it, a memory location can be set to a particular state by various methods. It might be a front door, read or write. And in that case, we would color it with these various colors showing that it was a particular front door or bus side, if you will, read or write out there. It might be a backdoor access like a peek or poke. So we visualize peek and pokes as different colors. So you can quickly look at what color it is to understand whether it was a front door or a back door access. In addition, you can do these memory arrays with things like file loading. Okay, so maybe you've got a MIF file that you have that you actually want to load with a particular preset values, and you'd want to see that particular color as something different. Maybe it's a virtual fill pattern where we've filled it with the same value for the whole memory array, or maybe for a range of the memory array out there. So basically, all the various ways that you could actually set a particular memory location are visualized with a different color. Just like our protocol level debugging, you can synchronize everything together. Okay, so this memory array view can be synchronized with your transaction view out there. And all your scrolling in time and all that will work just as effectively as it did before. I don't happen to show it here, but you can have multiples of these transaction windows. And maybe if I'm doing a memory controller, the other side is AXI. I could have an AXI bus up here. Okay? I probably also would have my simulation log file over here. Just like in the protocol visualization, all these windows can be synchronized together. And in addition, just like the protocol debug, you can pop up a waveform view and synchronize it with your DVE or your VERDI waves. Okay? So again, what we now have is a very consistent environment for doing protocol debug, both for standard protocols and for memories that you can use for everything and not have to have various tools for various types of debug. You have one integrated, unified environment for debug, both protocols and memories. If you want to find out more, go to synopsys.com/VIP. Thank you.